in the midst of drought, I think the most important thing is mitigation, which means we have to adapt. So maintaining a high spirit is very important. Therefore, I decided to put an AI photo to call for the cat that I think the whole nation really loves. First of all, is that what would drought look like in the future? Now, the first thing is looking back. So what you're seeing right now is a very popular drought index called PDSI, Common Drought Severity Index. It has a very heavy weighting on soil moisture. So you can see that the boundary I pick up is pretty much where the river delta is. Okay. You can see that we are seeing some sort of a change. There are two. The first of all is that there's a fluctuation contains multiple frequencies. We see this very sharp edge. This is monthly data. So you see this interannual year-to-year variability that presents this very sharp edge. But you can also see slow changing variabilities running for about 10 to 20 years. So this is something that is very characteristic of drought because soil moisture is like a coffee filter, right? It filters all the noise and then it drips out low frequency signals. So if we understand this signal, it can come back to help us to predict drought. But I think the more concerning feature is the long-term trend, which you can see from this solid red line, which indicating that the drought appears to be getting worse and worse. Now you can also see from all these peaks at near -4, drought has become more and more severe. There's a higher frequency of a more severe drought. There's also a changing climate effect. So we can see that drought indeed has become more and more severe in the recent time. To understand the spatial pattern, the straightforward way to do that is to do a correlation map analysis. Now, I make a little video to show you what the one-point correlation map is produced, okay? I'm using Western US as an analysis, as an example. Let's just say that for any locations, you can pick up one location and you will tell you the drought index that looks like this in the time series, right? Now, if you go pick the next station, because these are so nearby, you will have a drought variability very similar to the other location that give you positive correlations. Now, sometimes you pick up a faraway place, you will tell you something that seems to be negatively correlated, okay? And you pick up the whole region, then you can apply this analysis to the whole region, then you pick up something very positively correlated, negatively correlated, or just has no correlation at all. Then you apply it to the entire grid box that gives us some sort of a special pattern. Now, this pattern is very important because they help us understand how localized or how regional our drought pattern is. That way we can understand that if there's a drought in Thailand, would that be a Thai thing or would that be a Southeast Asian thing? Or would that be the global scale pattern? Okay. So with that analysis, we can apply this index onto the drought data set across the entire region. Now, this is the result showing you that when central Thailand is in drought, right, and you can see that the radius of inference covers pretty much the entire Thailand and some of the surrounding regions, but the correlation then drops very quickly. So when there's a drought in Thailand, or I should say central Thailand, you can tell from this very simple, straightforward analysis that it is a somewhat local feature. So there's a good news about it and there's a bad news about it. Occasionally, probably more than 30% of the time, that when Thailand is in drought, Philippines could be in drought too. So that suggests that we might be linked to some sort of a Western Pacific pattern here. The more we understand this kind of features, the more the information the Mother Earth will give us to help our prediction. But overall, you can see that Thailand's drought is very regional. It does not concern about anywhere else. Now, you can, with the same time series, to conduct the correlation map onto the ocean temperature. This is the direct output from sea surface temperature anomalies after 1990s. I'll explain why. Responding to this time series. So now people would immediately or intuitively think this is a ENSO pattern. And yes, indeed, there are some correlations. The other thing I noticed is that the variability of drought in Thailand is correlating with ocean pattern or Pacific patterns stronger and more strongly after the 1990s, or I should say after the 1970s, and then start to pick up to be significant after the 90s. That means that the ocean becomes more and more important in influencing Thailand's drought. And that is good news because predicting soil moisture or rainfall locally is almost impossible. But the ocean, because it presents a large-scale forcing and because it changes so slowly, it somehow can give us some lead time to help us predict climate. Now, this is something that the same analysis, you can see much lighter colors here, which means much weaker signal. That's when I correlate the entire index from 1900 onward instead of 1990. So you can see the difference between the two maps. This becomes almost insignificant everywhere. Now, I'm starting to introduce some sort of a research that myself and also Adanoy have done participate before. This is one example collaborating about the Jabaya River peak flow using tree ring data. So this group of scientists, they analyze tree ring records and not only the ring width, but also the isotope analysis, which can translate to more or less precipitation year after year for the past 270 something years. Okay. And the result, number one, they acknowledge that El Nino and ENSO does modulate the Jabaya River stream flow. Okay. But the level of this modulation is dependent on ENSO variance. Now, it means if we have a strong ENSO or we have a stronger ENSO theta connection, now the second point is that the number of high flow events, which has the implication to flooding, increase during La Nina events. So that increase fluctuate at the decadal time scale. Referring Jabaya River, you can see that starting from 1800 to the present time, even the tree ring data is showing more and more extreme dry events. So I understand that in 2011, Jabaya River floods that caused a lot of national disaster and a lot of damage. And Adanoy was the first to publish a climate diagnostic study about that event. This analysis shows that such an event might reduce because you can see extreme flood events after 1960s has a trend of decreasing into more drought. Now, I want to introduce a different diagnostic tool called the EOF analysis, or some people call it principal component analysis. This is an introduction to that. I purposely put in the OTV because this was the presentation I gave in 2015. The EOF analysis is a statistical tool that if you throw at it many, many different points of data, you will see pattern for you, okay? And then you will organize the patterns into groups, and give it proper weightings. In this case, you see the yellow dots represent the first EOF, okay? The red dots represent the second EOF. Then you can apply that to drought data, grid point. I'm using USA as an example. This is a grid data. You put it into the grid data, it will show you different patterns. Now, this is the second EOF. And then you can also show that the first EOF, usually their pattern are vertically or horizontally shifted. Okay, there's a mathematics reason for that. But so if we apply the EOF analysis onto drought data over Thailand or this domain, now this is the first mode. It accounts for about 35% of the variance. So which is quite big because the second mode accounts for about 14% of the variance, showing this north-south shift. And then this is the time series, low frequency variability and long-term change. Now, by looking at this time series, and it is changing from negative to positive, right? Which means this pattern for the past 120 years has been pushing Thailand to be more and more drought. So they really understand what is causing this north-south shift. Could it be ITC shifting? Could it be a delay of a monsoon season? You can see this drought map that the heaviest weighting is in northern Thailand. And then, of course, then it will reflect onto Chopaya River because it's upstream. So we also see a very localized feature, right? It's almost centered within Thailand, even though my domain includes other countries. Now, if you see this dark red, happening in Vietnam, that means over into China, the majority of the drought variability happens there. With the EOF analysis, you also output something called the principal component time series. So this time series, starting from 1900, we didn't see the trend here. The trend happens in the next month, which means it's mostly natural variability. The climate change impact is not reflected here. So this is our baseline. And you can also conduct statistical analysis. This is called wavelet spectrum. Don't worry about the details. You just pay attention to this color here. It is the statistically significant increase of a variability, which means that even though I just said this is a natural variability, but it is influenced by global warming in terms of amplitude change. So because you are seeing the drought variability has increased. So that is bad news for farmers, for water managers. Then you can also compute the pulse spectral analysis. It says that you have different significant frequencies. So we have about 15 years of a cycle, 9 years of a cycle, or 30-something years of a cycle, right? Similarly, then we can use this index to correlate with the entire world's ocean. Now we are seeing a similar pattern that somewhat resembles an El Nino or La Nina, but I'll talk about why it is not just that. But anyway, you can see that this pattern, that is the dominant drought mode in Thailand, correspond to this ocean pattern. So if we can understand or monitor this ocean pattern, there's a chance that we can forecast the drought in Thailand pattern. It is not so simple. Now let's take a look about this pattern. I can immediately identify 3 different variabilities. Okay, the first mode is called PMM. It's called Pacific Meridional Mode, which means this is the North Pacific north-south change of the pattern. Meridional means north-south. So you can see this pattern here, and there are papers who identify this kind of pattern. They also argue that this is a middle latitude pattern, which can be separated from the tropical signals. I think 10 years ago, the PNM pattern started to gain traction because they realized that PNM used to be considered a precursor, a leading pattern of ENSO, only that. But then people start to understand that no matter what you do, the PNM pattern always is present. It means it has some sort of modulation power, okay? So they create an educational website dedicated to this PNM pattern. You can see this pattern. The two of them are very alike. And then you can see from the cross-section in the tropics that there is some ENSO dynamics embedded there as well. Then you can see there is a South Pacific mode. That's time series consists of high frequency variability, but also the very strong decadal variability here. That could explain why the drought in Thailand, the drought index has such a strong decadal signals, low frequency signals. Well, if you move to the tropical oceans, there is a variability mode that is not many people focus on. That is called the Nino 4 or Central Pacific region. It has a very strong decadal, and it is very strong. This is the Nino 4 index here. You can see that there's a slow increase because of the global warming, but embedded in that, it is also a very strong decadal variability. I just hand draw this, but I have done spectral analysis in different papers that shows the decadal mode from 9 to 16 years, center around 12 to 13 years is the dominant mode, no matter what data set you use. So I'm very confident in this mode. In the earlier analysis, trying to understand drought in Nepal and monsoon rainfall in Nepal, I have found that the Himalaya mountains, especially mountains, they capture this decadal signal of rainfall. And you can trace it to the global pattern. This is different years. Year 0, 2 years before, 4 years before. Okay, here's 2 years after, 6 years after. You can see this global divergence and convergence pattern, almost like the Walker circulation, they propagate. So Nepal's monsoon rainfall respond to the Nino 4 regions, ocean temperature, 2 years before. Because 2 years before Nino 4 reached the peak, you can see the strongest convergence or divergence of water vapor converging into Nepal. But you don't see that elsewhere. You don't see that in flat plains. You see that on the slopes because higher terrains, mountains, they blocked moisture. They filter out high frequency signal, leaving more of a lower frequency signal, just like soil moisture did for drought. And this is another paper I participated in from my colleague in Taiwan, because they also found that Taiwan's rainfall over 150 years of observational data shows a very strong decadal variability. Okay, and depending on the era, before and after global warming effect, they respond differently and actually oppositely to Nino 4 patterns. I'll skip the details. The point here is that Nino 4 is a very important indicator. So you can do the similar analysis elsewhere, like shift the box a little bit to Isan regions. And Isan regions, you can see the trend disappear, leaving just the flat trend of the drought variability. But you can also see that the variance start to increase in recent times. And it also shows a strong Nino 4 signal. Even better, if you use Nino 4 index and to compute the cross correlation with the Isan PTSD, you can find a 4 to 5 months lead time in which, by using Nino 4 index alone, you can already have some prediction powers to drought over Northeast or Isan region. So I'm trying to converge here to push the drought prediction research and development forward. We have to understand 3 things that's listed here. The first thing is the types of drought. Now, many of you understand that there are many different droughts. There are agricultural drought, there are meteorological drought, hydrological drought, and there are flash drought too. Flash drought is something the US has starting to pay attention to only in the past 10 years. But here, I wanted to call for a drought type that nobody really pay attention to, but it's utmost importance. It is called, I don't know how to call it. I call it conceivable drought or drought perception. The reason is who determined mitigation effort? The government. And who runs the government? The politicians. So, and who elected politicians? People. So if people think their farm or their land is in drought, it doesn't matter what kind of drought, right? We can argue that, well, PDSI hasn't reached -2 yet, or hydrological drought isn't that bad, but hey, their crop is dying, their land is drying, they think it is in drought. The next thing is pure meteorological diagnostic study, drought forcing. Now, I just explained that this simple correlation pattern in the Pacific Ocean already consists of 3 known patterns in the literature. Which one contributes the most? Which one is more important? Or how do we capture these 3 altogether? Because the 3 most, even though they are correlated, they are not the same. Then drought prediction is to utilize computer models, global or regional climate forecast models. Now, I'm showing you an example performed by Azang Noi with the focus in Taiwan to see that if we can use the empirical result to forecast 1 month before, and then the climate models can forecast the SST pattern for another 1 month. Guess what? We have 2 months of a warning lead time. That's the outlook of this paper. Okay, so it takes work, but for localized features, there's no other way. You have to do research. Otherwise, the direct model output will not give you anything. And more recently, for the palm oil yield in southern Thailand, in Surat Thani, and we try to understand the response to rainfall, moisture, and the ocean patterns, and we found out that, again, this is Nino 3.4. There's no other private research have combined all these things together and suggest that there's a way for seasonal predictions for Thailand's emerging palm oil industry. So this is the ending just showing that Thailand heat wave gives Vietnam edge in durian exports to China. Guess what? You know, we can claim to be #1, but there's a climate event, extreme heat, and then Vietnam didn't have to do anything that surpassed us. So in trade markets, it's very cruel. In preparation for the next one coming, I just said that the fluctuation is real. It will come back for sure. And next time we will have a better tool. So it's basically my summary of the drought prediction of these 3 things as humble suggestions for how can we move forward, including empirical forecast, dynamical forecast, and diagnostic analysis. Thank you for your time.